In my previous videos on the AP exam and taking their multiple choice, I said you're not expected to know everything there is to know about chemistry for the AP exam, because College Board knows that you are not a chemistry teacher, nor are you a chemist by profession, nor do you probably have mountains of hours in a chemistry lab. Now hopefully over the course of your time in AP Chemistry, your chemistry teacher will have you do several labs. And in the course of that time, you hopefully will see all of the things we're about to talk about, all the solutions and all the gases and all the possible permutations of colors that can occur, but you might not. So it's okay if you don't know what color something turns. It's 1 point. Whether or not you know it or whether or not you don't, it's 1 point out of the 1,000 some odd points that you can get on the AP exam. So really we're talking the difference between a 3 and a 3 1/10 rather than say a 3 and a 4. But if you're in my class, I give you net ionics quizzes every week, but those are pulled from full and complete AP tests. And the net ionics questions sometimes ask you things that we haven't necessarily covered yet. So you might not know what color an indicator turns. Hopefully you do, but you might not. So in the interest of being fair and by popular demand, and because I was afraid one of you would try to stab me if I said no, I will make a video now about the colors that certain solutions and certain things can have at a given time. And no, you don't have to memorize them. This is something you'll either remember or hopefully have seen enough that you can remember it. So first off, the general rule of thumb. If something is in an aqueous solution, meaning it's in water, and it is not a transition metal, so any group 1 metal, most polyatomics, any non-metal, the solution is opaque or clear. If it forms a solid, so any salt, and there is no transition metal, go ahead and say that it is white. The solid is white. Okay, you can't, this is a generalization, so if you're a chemist and you're watching this and you are offended at my generalization, well, I'm not sorry. Don't get offended. It's for high school chemistry kids. If it's not a transition metal, assume it is white. Now, transition metals are different than representative metals. So groups 1, 2, sum of 3. Because transition metals have unfilled d orbitals. And because they have unfilled d orbitals, they develop a color in solution. And their solids typically have a color. But if they do have a full d orbital, like say zinc, zinc has 10 electrons in its d orbital, that means that it has no color. Zinc in solution is colorless. It is a solid, it is white. So let's talk about some that are unfilled, the biggies that you're likely to see in a solution. Let's start with copper. Now I apologize, I had hoped to find a picture of our periodic table that did all this for me on Google. Google let me down. It's a very sad moment in my life. I need a moment to collect myself. Okay, so copper. Copper can come in 2 forms. It has 2 oxidation states. You can have copper 1 with a +1 charge, or you can have copper 2 with a 2+ charge. Now copper 1 is colorless in solution, while copper 2 is like a deep blue. In my class, you'll see this when we work with the pennies, when I show you how a penny can be dissolved, or quote-unquote dissolved, by concentrated nitric acid. The solution that's left over is dark blue because of the copper ion in solution. Nickel forms nickel 2 in solution and is a palish green color, while cobalt is a not green. It is pink in solution. Iron has two oxidation states, can be either iron 2 or iron 3. Most of the time you'll see it as iron 3 in solution, and it is like a brownish, a murky color, kind of a doo-doo brown. But it can also be like an off brown greenish color. So I represent it by like a pale green. It's kind of like nearish the brown side of green, like an olivish green. So if it's green, that means that it's iron 2, or like a palish brownish green, it means it's iron 2. But if it is brown, the solution is iron 3, 3+. Manganese can be a light pink if it's manganese 2+, or it can be a deep or a darkish brown, not as dark as iron, but pretty close to being if it's iron 4. I mean manganese 4. If it's manganese, and I didn't have room on this card because I didn't think I could zoom in this much, and I honestly can't. But if it's manganese 5, if it's manganese 6, it's a dark green, like almost a foresty green. And if it's manganese 7, it's a purple, like a lavender, darkish purple, depending on the concentration. Okay, so manganese, I can tell you right now, with that many variations, it would not be very likely that the AP exam is going to say, you have a solution of manganese 4. What's the color? Why? Why would you need to know that? But just to cover my bases, there are 4 for manganese. Oh, and I lied. Iron 3 is not like a doo-doo brown. It's like a yellowish brown. Kind of nasty. Now the rest of the transition metals you can probably figure out on your own or come up with some idea. One that I forgot to highlight on here, tin. Tin in solution is usually clear. If it has a precipitate, tin precipitate is a yellowish color, like a faint yellow. Let's talk about the halides. Fluorine gas, diatomic fluorine, is like a pale green, almost a yellowish green. And chlorine gas is yellow. Not this vibrant, like canary yellow, but yellow. Like definitely, if you look at it, go, that's yellow, and that's chlorine gas. Bromine gas is brown, is a brownish orange or burnt orange look, and iodine gas is purple. And if you're in my class, when we go over states of matter, I will show you iodine crystals subliming. And if you ever want to see that, I suggest you look on YouTube. It's actually kind of cool. You start with these little purple crystals, they turn into this purple gas, and then they end up as purple crystals. So it's kind of cool. All right. So besides just elements on the periodic table, polyatomic ions can also have some color. So the dichromate ion is an orange-ish color. Actually, this is the picture right here. It's what it actually looks like. It's orange. Chromate is yellow. Permanganate is purple. And in my class, you worked with permanganate. It was the one that we used with the hydrogen peroxide. And it was the purple stuff that you were titrating with. Let's talk about indicators. An indicator is something that changes color in an acid or a base. Phenolphthalein is a very common indicator, and the AP exam expects that you know what phenolphthalein is and how it behaves. So phenolphthalein is an indicator that changes, that's clear in an acid or pink in a base. Another common indicator you're expected to know is brothymal blue. And brothymal blue is either blue or it is yellow. It is not green. That picture shows, oh, 6 is green. No, 6 is not green. It's yellow. All right? So brothymal blue is either blue or green. It is blue blue or yellow. It is blue in a base and yellow in an acid. And remember this from my class when we did the electrolysis of water. I put both electrodes into one petri dish, and it was blue on one side and yellow on the other because hydrogen ions were building up on one side and hydroxides were building up on the other. And that's all the colors I could feasibly see you being asked through the course of the year.